Edge placement, again, is done with all of the non-bandaged components. So this is the top, this is the bottom. I can do it with the white side first. I'm sorry, with the red side first. I've got 2 whites and a red. And this is done very similarly. So where's the other red and white? Actually, why don't I do orange first, because this is already in. So I already got that in. So this will be my workspace over here, and I've got 2 orange and yellows. So I'm just going to move this over here. Got to move this into the workspace. Now I've got to move this back. Double turn and move this back. Okay. So where's the other yellow and orange? Right over here. Okay, so I have to move this in. So turn it like so. Being careful about alignment. Almost did a little corner turning there by accident. This comes here. Corner cutting, rather. Corner turning. And this comes over here. Okay. So now this will match up with this. Now notice these 2 are matched up together too. Might I be able to coordinate that? And the answer is no, not yet. 1, 2. 1, 2. All right, so now I have these in. What I'm going to do is I'm going to move this off of my work site to here. This will join this over here. So bump it out of the way. Double turn and move this back. Okay, I don't worry about these yet. Those I can easily put in. You saw how I did that before. Okay, so what else do I have here? I've got these 2 greens and oranges that I've set my sights on. So I'm going to put this one in. So move this in. Double turn and move it out. Okay, upon doing that, coordinate this guy with these guys here. Double turn, and now we can work on getting this back. Kersplat. All our centers are back, and now we have this edge. So now we have 1 more orange to go. Got to move it out of the way, can't move it here or here, so I got to move it over here. So it doesn't really matter which one. Turn. Turn and turn. Okay, the last orange is left is the blue. Here's the blue over here. There's probably another blue here. So this will match up with this guy over here. So double turn, we got it. And now this one has to move in, so I'm just going to double turn this all the way over here. Now I got to remember, orange is on the top. It's going to get kind of confusing if I forget about that. Turn and turn. That was pretty slick, huh? So anyway, this is all in here now. So I'm going to move this out of the way to join this orange over here. Turn it like so. As we're getting back to the cuboid form, the movement is getting easier as alignment is getting easier to see. Turn and turn. Okay, so now I just have to turn these back. Move this over here, get my centers back, and lo and behold, here we are. Okay. And this is all lined up. So what I have is I've reduced my orange edges. The reduction of the other edge, well, that's going to take a little more doing. But let's go ahead and put our orange cross in. So here's orange. This goes with this over here. This guy's going to come up to here. So we're completing our edge reduction. Turn, turn, turn. This really is all typical cuboid strategy. I'm not reinventing the wheel or the cube. This is good, this is good. Where's our other ones? Right here. So here's where the white one is. Again, this is more for demonstration purposes than anything else, rather than tutorial purposes. If you're buying this, you kind of have an idea of how to solve cuboids, I'm sure. And turn. Okay, here's our cross. Good, 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 good. Doesn't even matter if we have the cross, but now, how do we do this? Well, if this were a floppy, we'd end up potentially getting the floppy parity. It's not a floppy. We did not have shape shifting along this axis, so we don't have to worry about that. But what I'm looking for is I'm going to reduce these edges here too. I can't worry about these because they're bandaged. So I'm looking for two corners that are in. If I don't see them, then I have to put them in. So let's say we're looking for this. I need to put a white corner in here. This isn't the white one, but this is. So what I'm actually going to do is I'm going to have to take this edge group and put it over here so that this white one could be right next to this. Then I can look at these two as corners. And this is the edge. Confusing? Not really. But anyway, we're going to do an edge swap to get this group in here so that this white can end up here. So this becomes my R. What? No, actually, my apologies. This is my R. 2R, U, to R, U, to R, to U, to R, to U, to R, U, to R, UI, and last but not least, to R. What I like about giant cuboids or giant cubes, well, mostly giant cuboids, is that it gives you a chance to use very similar algorithms, if not the same algorithms, just in a slightly different way with different perspectives. But my point was to bring this close to here. So now I can use this as my R and do a corner swap to bring this to here and this to here. It's actually not really a swap of these two. This stays the same. This and this comes here. Well, you'll see. Anyway, 2R, U, 2R, UI, to R, UI, and then a deep down D, then finish it up with to R, UI, to R, U, and finally to R. Okay, so now lo and behold, I have these corners in. These aren't in, but this puzzle is now getting more recalibrated. To get this in, I have to make sure that this yellow is over here now. So I can't solve it. If this were like a normal cuboid, it would already be in place, but it's not. I have to treat these like these are the corners and this is the edge, even though these are collectively the edge. So there's a degree of pre-assembly that has to happen. In any case, normally you'd hold this to the side, to the left, do the corner swap again, but I'll end up swapping the wrong thing. So I gotta move this into here. So these edges are gonna be swapped with this. So now this is my R again. Do an edge swap to R, U, to our U, to our to U, to R, to U. Every so often I have to put on a flat surface just to make sure it's calibrated. To R, U, to R, UI, and to R. Okay, so now I'm ready to actually do that step. This is still in, yellow's here, and now it's an edge swap, a corner swap rather. So-called corner swap. To R, U, to R, UI, to R, UI, DI, to R, UI, to R, U, and to R. Okay, good, 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 and good. So now we treat these still as edges, and we go ahead and do our edge swap. So I'm going to move this blue to here, and do our, actually we can also, I guess, move this if we wanted to. Opposite edge swap, to R, to U, to R, to U, and to R. Okay, we did create some placement parity here and here, although we put this in. So now the next step is let's go ahead and do an adjacent edge swap with these. And all this just to get edges and centers so that we can do a cuboid solve, so that we can get back to the cuboid form, so that we can do 180-degree algorithms to solve it. It's as simple as that. So we've got to our U, to our U, to R, to U, to R, to U, to our U, to our UI, and did it work? To our, and yes. So all these edges are now reduced, or these portions of the edges. Remember, we're just doing 5 by 5 stuff. This is kind of like the equivalent of a 5 by 5 by 1, 2, 3, 4, 5, 6. I'm basically doing a 5 by 5 by 6 solve. In other words, this. I basically just did this solve here. This is a 5 by 5 by 6 made by Tanner Frisbee. And what you saw me do is pretty much doing edge reduction, just like these three, 1, 2, 3. And you saw me doing center reduction, just like these, 1, 2, 3, 4, 1, 2, 3, and the top over here. So that's exactly what I was doing. 5 by 5 by 6 solve. That's what I'm doing right here. I guess maybe I should have said that to begin with. Now that I've done that, the way that I continue my 5 by 5 by 6 solve is once I have these in, I don't worry about getting the top one in. I start putting these guys in over here. That's what I'm going to do with this. So continuing my 5 by 5 by 6 cuboid solve of the 5 by 6 by 7. Now that I have these, this is my bottom layer. I'm going to start filling in these layers here. 1, 2, 3, 4, 5, 6. So I'm going to be putting these in first. Okay, I'm going to pick it up here. I actually just coordinated these in the right place. Doesn't really matter though. So white and green. So I'm going to try to find a white and green over here. Here's a white and green, but it's very happy being up here. You can see because it's matched up pretty well. Let me raise this bad boy up. Okay. So this is okay over here. If I were to flip it down here, it's gonna be opposite. Now bear in mind, the way that I solve these bricks is I ignore these parts here. So I just did the center here, and these are the edges. So these I just ignore. Is there another white and green up here? If no, we move on to our U, to our UI, and to R. UI and to R. Now I'll tell you that these middle moves in the shape-shifted form are the more challenging of moves, but it'll do it. Alright, so now we do the top layer. So with this, knowing that there's not going to be any floppy parities, I'm just looking to see which one has corners in. These two. So this has no parities with it whatsoever. So I'm going to move this over where it's supposed to be, to the left. So I know that the white one has to be here, and it's over here. So now we're going to do the corner swap in order to get this over to here. To R. Wait, now it's just a question of middle swaps here. So I want to put this into here. This portion of the 3 by 2, these two layers are fine. Now we just jump up a layer and do these two layers. 2R. All right, this is down here. Now we're ready to go to the next one. This serves two purposes. Put this placement parity back in and solve for that. Let's move this into a nice position here. How about green and yellow? This one. 2R, U, 2R, UI, and 2R. Obviously these layers are a little easier to deal with. And now we move next one. This one here, yellow and blue, and we should be good, which happens to be this guy over here. To our U, to our UI, and finally to R. Okay, so this bottom portion here is done. Now we just come over to here. So where are our two corners? Right over here. We'll move this to the proper corner place, move it to the side, green is here. So we'll just do an adjacent corner swap, so-called. To our U, to our UI, to R, move it into a UI, and DI to our UI to our U and to R. Okay, we just move this guy back. So now we have our corners in, we just have to get the centers. We can do a clean swap of these two and a clean swap of these two, if you can see it. Anyway, we'll swap the green and white to our U, to our U, to our 2U, to our 2U, to our U, to our UI, to our U, to our U, and of course these outer layers do tend to be more easier to move. To our 2U, to our 2U, to our U, to our UI, and finally to R. Now what's interesting is I finally freed up this layer. This is the first time I freed this layer up. So we are certainly getting there. Okay. We'll move this one in. And now to return ourselves back to the cuboid form as we continue our 3x3x 1, 2, 3, 4, 5, 6. 1, 2, 3, 6 solve. We now just do this bottom over here. So we've got these centers all in. So now we're just going to put in the orange ones as we see fit. So this one is going to come over to here. Orange, green, and white comes down to here. To our U, to our UI, to our, so this is going to come down here. To our U, to our UI, to R. Okay, so this is in. We created placement parity here. Because this is even number, that's going to be really easy to get back. But we'll get that, approach that when we get to it. So let's whip this guy around here. Right here. So this belongs down here. Blue and yellow. To our U, to our UI, and to R. And now we have this one to go. Okay, so all of our corners are in. Now we can get this in the real non-shape-shifted form, the one that I can use. Let's flip-flop these two. To our U, to our U, to our 2U, to our 2U, to our U, to our UI, and to R. So our marathon for this part is almost complete. UI, and now we have finally earned the right to call this non-shape-shifted. Bang. So we have it back to our native form. Now what? Now what we're going to do, this is the fun part of the brick solve, because with this we have it back to our native brick shape. You can almost actually use it as a brick, I think. And now we need to get these in with 180-degree parity algorithms, much like you saw with the Rubik's 180 algorithms. That's where this comes in line. And what I'm looking for is any points of symmetry. And there are a lot of them, and we could potentially have a brick parity, but I don't think we do in this case. When you look at it, I'm going to start from the outside, from the inside out. Starting off with these areas here, I've got 2 over here, and I've got 2 over here. So I can swap these two. So I'm going to move this like this. Now, anytime I do some swapping from the middle, it's going to translate it to the end over here. That's why I'm doing it from the middle on out. So then I can move it from the end. So forget these 3 together. That's not what I'm looking for. I'm looking for these 2 together and these 2 together. That's the kind of symmetry that I want. Even layer parity algorithm, bringing these 2 in. So you split it down in the middle and then just to the top. I'm ignoring these. That's going to be 2U, 2R, and then the 2F splits right down here. So then we split it again here, 2U, 2U. Then we do a 2F, 2R, and 2U. So this is in, these 2 aren't, and we might as well fix those now. Okay, so these have been completely put back in. This is actually going to be pretty straightforward, so I don't think we're going to see any brick parity with this. And move this over here. Okay, now we've got, say, these center ones over here, which can match up with these over here. So I keep looking for points of symmetry like that. 2U, 2R, 2F, 2U, 2U, 2F, 2R, 2U. So there's so many different layers that you can have these points of parity. So now these 2 and these 2. You know, I still got to say, and I don't know if I've stressed this enough, how incredibly stable this puzzle is. That nothing pops out despite all these pieces and all these tiny interactions. That, yeah, like I say, sometimes it may snag a little bit, but these pieces don't fall out. Now these 2 and these 2. Move this in here. And once again, 2U, 2R, 2F, 2U, 2U, 2F, 2R, and 2U. Okay, moves it to the end, do it again. So, how are we doing? We are almost done. As a matter of fact, I think we are 1 algorithm from being home. And that's, these 2 and these 2. So, join with me. Say it along with me. Last algorithm of this monster behemoth brick, the largest of bricks, 2U, 2R, 2F, 2U, 2U, 2F, 2R, 2U, and now this bad boy is moved back, and there you have it. First time seeing the solve of the 5x6x7, 5x6x7 brick cuboid. Again, the thing to note is the great stability of this puzzle. Now, I could do more lubrication. There is a little bit of stiffness, particularly in middle moves like this, when it's in the shape-shifted form, but otherwise it's a very stable puzzle. It does not pop. There's a little trick that I had to do to keep it aligned so that I didn't have to keep taking it apart, but otherwise it's a good-looking puzzle. Now, I did not demonstrate the brick parity with this particular puzzle, so I leave it to you to get this puzzle, try to solve it, try to use the techniques that I'd mentioned in previous brick tutorials on how to get out of brick parities. If you run into trouble with it, you're welcome to do a viewer request, but only if you've tried it. Anyway, thanks for watching.